Hello, this is Tom Wildman, and I'm at home by Zoom video, and I am with Jake Kurzweil. He's going to be the videographer, and I'm with Laura Leonard, and she's going to be doing a sample preparation, looking at it. And our objective for this session is to make certain that the sample kit is all set and all the meters and devices that we use while sampling are in good working order. I introduced Jake the last time when we were doing the sampling at my home. So let me ask a few questions of Laura here and introduce her. She's a bicyclist. If you don't know it, she is the president of the CSM Bike Club, which it was a national champion, wasn't it, Laura?
Yeah, we've won 3 years now. I'm not the president anymore. I passed it on to an undergraduate student.
Oh, well, good, but still, you did great organization there. And also, Laura has one of the neatest thesis projects I know of. So could you explain what your thesis project is?
Sure, yeah. So I'm actually studying in Crested Butte, Colorado, into environmental perturbations. So I'm looking at specifically bark beetle infestation and the impacts of that on our local soil and biogeochemistry. I'm also hoping to look more broadly at our watersheds as well and how climate change, bark beetle infestation are affecting our water. Yes.
Okay. So the first thing we're going to do is investigate the sample kits. So the first thing we're going to do in this preparation is investigate our sample kits and go over the equipment list and see just what's in the kit. And why do I worry so much about what's in the kit? Well, Laura, when you go up to Crested Butte, do you have a list of the things you're going to take up when you're going to sample?
Yes, I do. So when I go into the field, I have to make sure I have everything I need because it's a 4-hour drive. So if I forget something, that's it. And I actually have forgotten some of my syringes for water sampling, and I couldn't collect crucial water samples for one of my trips. So I learned that day I need a list.
Yeah, well, after doing that many times, I know that I need a list also. First off, Laura, is there a plant spray squirt bottle in there?
Yes, we do.
And is that filled with deionized water?
It is. DI water.
Okay, I want to make certain that there's a Sharpie in there. Okay, it's there. And we have all the centrifuge tubes and syringe filters. Okay, and I think that Kate has put in some 60 milliliter amber glass bottles in that kit too, did she?
In our other smaller cooler that is currently our tripod.
Oh, okay, yeah, but you have a camera. You have a camera on that, so we'll check that. We'll check that later. And it also be when Jake takes that camera off, we can check to make certain that there is a standard operating procedure in that small cooler and a chain of custody sheet in that small cooler also. And so those will be important. There should be a field book in there, Laura, and I want you to take that out also. Okay, so we're going to use that in a few moments here. So the next thing we want to do is introduce the measurements we're going to take in the field and check out all the instruments to make certain that they are all working before we go into the field, just in case. We're going to take 3 measurements in the field when you're out there. It's going to be conductivity, pH, and alkalinity. We're gonna actually measure golden water and record the results in our field book also. So let's start out with conductivity. Let's see the meter and the conductivity probe there, Laura. Okay, there's a probe. Notice those slots that are in that probe. you have to, when you're taking a conductivity, you have to make certain that the water fills the slots, okay? And conductivity is a very easy measurement to make, and it's very stable. And so that's one of the reasons why we do it in the field. It's always certain to be a reasonable measurement, and also it gives us a good indication of how bad or good the water is. What does it measure? It measures the number of ions that are in solution. Really, all we need to do with this conductivity meter in preparation is put it in the standard and make certain it checks out okay with the standard. What is the standard?
1,413 microsiemens.
Oh, yeah, yeah, the units are microsiemens per centimeter. You know, what is a microsiemen? Well, I guess you have to ask the French. They're the ones that made up the unit.
It is stabilizing. So we're at 1,435 microsiemens.
That's just fine. Just around 1413 is okay. I want you to record that value in your notebook. Okay. Now, conductivity does change with temperature. So that's one of the reasons why I'm not really worried about whether the standard is at 1413 exactly. Okay, notice that after Laura was finished, she wiped off the probe. I mean, she rinsed off with deionized water and then wiped it off. And she had you have a waste beaker out there too, Laura, to do that, huh?
I do.
Yep. That's always good to have out there when you're sampling too. Let's measure now golden water. There's the golden water. What are you going to guess it's going to be? Well, you can see. I'm going to guess maybe between 200 and 300 microsiemens.
What is Jake's bet?
I'm going 350 because of the chlorine.
Jake says 350.
Now, I don't know if it might be up that high.
All right, we're at 569 microsiemens.
Wow. Okay. Now, okay, all of us are surprised. Okay, so you're going to record that value, Laura, and do it 2 more times just to make certain that we know what we're doing. Notice that she has that the slots in that probe below the water there.
To calibrate this probe, I tested my tap water in my apartment. It was 750.
Really? Boy, I don't know if I'd be drinking that, Laura.
All right, so we have 3 measurements now. The first was 569, the second was 561, and the third was 556.
Okay, that's good. I mean, that's usually what I see for conductivity. There will be 3 measurements and reasonably close. And so that's one of the reasons why it's really nice to measure conductivity out in the field, because, you know, we now have an indication of what is in our water. Our next measurement that we're going to do and check out our meter is for pH. Now, Laura is using a multimeter so that she is going to take off the conductivity probe and put on the pH probe first off. And while she's doing that, I'll say that taking pH is a very difficult measurement. It especially is difficult in the field. And that's why we definitely have to standardize the pH meter. We're going to check that it's standardized and worked in the lab, because at least every now and then, pH, you get the meter out there and it doesn't work. Notice that Laura is taking off a probe storage solution, a little thing. We always try to keep that probe moist. What I want to show you is that right at the end of the working part of the probe, there is a glass bulb. Do a measurement what has to happen is you have to get current through that glass bulb because you have an electrical circuit that measures the pH. And so you got to get current through that glass bulb in order to complete the circuit. Let's start standardizing the probe, see how we're going to do there, Laura. Now Laura has two buffers there. The yellow one is 7, pH 7, and the pink one is pH 4. And notice she grabbed the pH 7 buffer first. So let's start there, Laura, and let's see how we do. And it's going to take a little bit of time to stabilize, but these hot multimeters stabilize pretty fast. How did it standardize?
7.04.
Let's try the pH 4 then. Notice that she's going to rinse off the probe, and she'll probably dry it off to make certain that she doesn't contaminate the pH 4 buffer with the pH 7 buffer. Okay, so she's going to hit the calibration button again. Okay, so how do we do in the pH 4?
3.99. Oops.
Okay, so it's calibrated. Good. Okay, now what we do, just to make certain that this pH meter is working and the calibration was correct, I'm going to go back, Laura, to the pH 7 buffer.
Okay.
And I'm going to read it as if it were a sample. And it ought to read 7 plus or minus 0.05 pH units. Let's see how pH 7 works.
7 on the dot.
7 on the dot. Okay, that's great. So we know it works. Usually, if I have any questions about a pH meter when I'm in the field, it'll usually go bad in about the first 10 minutes or so. And so, if you have any questions about that when you're in the field, just go back and check the pH 7 and see if it still is within that plus or minus 0.05 pH units. Okay, now let's take the pH of golden water.
It's important to not just set it down at the bottom and leave it, but to leave it suspended. As you can see, 8.18.
8.18. Okay, let's record that. We're going to have to take 3 measurements, because especially for pH, one measurement, you never know whether one measurement is going to do it.
Well, that was quick. 8.19.
Okay, well, that's great. Okay, so that's really very close. One thing I know, oftentimes I've seen a drift in pH in the first measurement, second measurement, and third measurement. It might drift by about 0.3 pH units. And so it usually drifts one way or the other. And so then I have to take about another 4th measurement, maybe even a 5th measurement, to feel confident that I know the pH.
So we have 8.18, 8.19, and 8.22.
Okay, so that's really good. Yep. Okay, so that does it for pH. Now the final measurement we take in the field is alkalinity. This is a measurement like pH that can change if you between a measurement in the field and a measurement in the lab. So we want to do it in the lab. Now the difference between alkalinity and pH is interesting because pH, I say, is an intensive variable. You could take the pH of a drop of water. pH will measure the hydrogen ion concentration in the water. Alkalinity measures how many ions are in that water that will buffer or stabilize that pH reading. And so it is an extensive variable and it'll tell us how much that pH reading is stabilized. And so Laura's in there checking out the supplies. We're going to do it with a titrator here, as you see. She has a titrator, and she's going to put in a concentration of sulfuric acid there. And I think you need the low concentration. the 0.16 normal one. The conductivity of the water tells me which one I'm going to use. If we had a conductivity of water that was above 1,000 microsiemens per centimeter, I'd probably use the 1.6. Okay. She also has, so she's going to put that in. She has the indicator for the titration, which is brome cresol green and methyl red. Christoph says it's going to go from green to red, and she has a wand that she'll set up. So she's going to set that up right now. Yeah, sometimes those cartridges are tough to put in. Okay, got it in there. Okay, then take that top off and put in the wand. I keep the wand in deionized water so that it doesn't, so it's somewhat clean as it comes out. So usually when I take the wand out and put it in, I give it a little shake to get the water out of the wand. So usually what is stabilizing the pH in the water, if it's a natural water, is primarily carbonate and carbonic acid. And so so really what we're doing on an alkalinity measurement is measuring the amount of bicarbonate in the water too. And so oftentimes we can oftentimes I use the alkalinity measurement to measure, to give me an indication of how much bicarbonate is in the water. Now she has her wand in there. Now she has to spit it out to make certain that the tube, that cartridge there in the wand is filled. And so she's going to squirt out some sulfuric acid, maybe at Jake if he isn't careful.
Wait until I see some drops come out.
Yeah, and usually you have to make certain that there's no bubbles at the top of the cartridge usually too.
All right, now I think I'm not seeing any air bubbles.
Okay, good. Now, Laura, did you set the titrator back to 0 again now? Okay, now she's all set. So we can set that aside. And now, because this alkalinity is an extensive variable, it's going to depend, how much we titrate depends upon how much water we use. And we don't want to be titrating forever, so that we are using this 0.16 normal sulfuric acid. I use that if the conductivity of the water is below 1,000 microsiemens. So this is a good reason to have a reading of the conductivity. But it's above 500, so I would use 50 milliliters of water instead of 100 milliliters of water. And now we have to add the indicator. We want the brome cresol green methyl red. There have been times when I've had really, really bad water and it has a lot of sediment in it, and I can't even see what the indicator color is. If that happens, you can use your pH meter and titrate to about a pH of 4. So now she's all set. You can see the solution turning green there. Yeah, okay, so she's set to titrate now. Let's see how she does. I'm seeing that there's not too much change right away, is there, Laura? You don't see any pink at all, do you? So you can titrate.
We're at 10 digits.
Okay. If you don't see too much change, then I usually do about 3 turns. When I get to close to seeing a change, then I go to 1 turn. So there's a lot of bicarbonate in golden water. Well, the pH is 8.1, so it's that's about where it's saturated with calcium carbonate.
Oh, I saw a little bit of purple.
You saw a little bit of purple, huh? Well, we're getting there then. So you want to get down to 1 turn. Yeah, I can see it changing a little bit in the color. This makes for exciting video.
Yeah. We're at a purple
Yeah.
now.
A little purple? Okay, so what I would do then, Laura, I would do this. Take that reading, take the reading on the titrator. Don't write it down yet, but just keep it in mind, and then put in just one more turn to see what happens. That's what I usually do in order to. Does it change? Well, I can see it changed a little bit more.
Yeah.
Okay, so we're there. Okay, how much do we use?
We did 188 turns.
Okay, so we want to record that 188, okay, in your notebook, in your field book. And we want to record the normality of the sulfuric acid we used.
0.16.
Okay, and now look on the look in the lid of the alkalinity kit, and you should see a multiplier there. You should see a number of numbers that tells you the multiplier. Yeah, I can see it there. Okay, so what you want to do is, it says for 50 and 0.16, there's going to be a multiplier, correct?
Yeah, perfect.
Good. Okay, so that is, so that gets that measurement also. And so I think we're through with the measurements. And it seems like everything is all set. It looks like our sample kit is ready. We know that our meters and everything work, and everything's in order in the meters. Now, when you go out in the field, there will be one more thing that you have to do, and that is that there's in that small cooler, there's a 2-gallon bag for ice. And before you go out, you have to fill that 2-gallon bag for ice so that you make certain that sample is that cooler's cold. Okay, and so then other than that, we're all set to go out sampling. Thank you very much, Laura, for doing that. Thank you, Jake, for doing the video, and that's all I have to say.